So, welcome to Talk with Tim. This is the second interview that we've done, and I think it's just going to be just a blowaway. Today, we have a great interview planned for you with Cree Edwards, who is challenging Einstein's theories. And Cree, welcome to Talk with Tim. Tell me, now you've got a theory that Einstein took us, he had some very clever ideas, the theory of relativity and some others, but then when we got to a certain point, and he was a little older, he pointed everybody toward particle physics rather than thinking about the world as ether, and it was kind of like a bifurcation. And you're saying that whatever that was in 1910 or something, 1916, we all went off in this particle physics direction. We've spent billions and billions of dollars, and we haven't really come up with anything. And so that has been a wasted path. Yep. And there's another path to go. So explain the theory, your theory, and how it differs from the direction Einstein was taking us.
Yeah, well, first of all, Einstein made a mistake, and to his credit, he called it out first, and he introduced his theory of general relativity in 1917. It took over from Newtonian physics. A whole community of physicists took off in another direction, which he sent them on down the path of relativity. In 1920, he came out and he said, there's a mistake. You can't imagine relativity without having an ether. But ether was the one critical thing he eliminated from Newtonian physics. And he tried to get it back in, and the community would not let him do it. And then in 1927, relativity failed at the subatomic level, and then it bifurcated. Quantum went one direction, and relativity went the other direction. So the big stuff was theorized through relativity, the small stuff is quantum. And at that point, if it was a self-correcting system, they would have stopped and gone back and found the first principles error, fixed it, and then moved on. But we're stuck now with Einsteinian physics, which is flawed at the foundation, and we spent the last 100 years digging down the wrong holes. And the unfortunate thing is they can't stop digging. They can't stop the gravy train. So we're kind of stuck, and there's little or no progress being made to ends of the theoretical spectrum.
And there have been Nobel Prizes for dark energy and dark matter. And tell me, do those make sense? Why have we gone in that direction, and why do we keep going in that direction?
Well, we went in that direction because that's where Einstein set us. And the physics community is ruled by, decisions are made by peers. It's peer review. So the Nobel Prize basically is the most popular physicist gets a Nobel Prize for whatever he's working on. The problem with physics is, the education is not actually it's closer to an indoctrination than education. Education, they want you to have critical thinking. They want you to question things. When you go through the physics education, 20 years worth, they tell you what to believe. If you start questioning it, you're not going to pass your test. You're not going to get your PhD. So what we've done is we've created this multi-generational cycle, educational cycle, that has eliminated that's limited the solution set for the physics community in an area where they cannot self-correct. And it's a tragedy because there's a bunch of brilliant people that know we're going the wrong direction, but the solution is outside of the Einsteinian theories. And if they suggest changing direction, they get excommunicated. They get canceled. They cancel physicists all the time.
So I'm in the venture capital business, and I am always looking for industries where they're run by monopolies or oligopolies, and those oligopolies looking at the world in a certain way, and they're centralized, and they make all the decisions at the top. And if anybody's making a decision counter to that, they're excommunicated. And so I'm always looking for entrepreneurs who are trying something new with new technologies, trying to break into that industry. so that they can form and grow inside that industry. So we're trying to challenge those theses or challenge those monopolies. Would you say the scientific community is sort of an equal monopoly? You think it's a monopoly, like CERN always gets a certain amount of money, and the U.S. government always gives a certain amount of money to the physicists, and all of that, and it just keeps growing the way it's growing. And there's nothing saying, there's no entrepreneur in this case coming in and saying, wait a second, they might have been wrong.
Yeah. And I think it's clear that they were wrong. The problem is that the entrepreneurs get selected against in college. The guys who ask questions in college and say, hey guys, this doesn't sound right. This is illogical. They don't make it into the physics establishment. They get weeded out long before they get to reach a peer level. The physics community is worse than most oligopolies in that they're self-policing. And the money that comes into the physics community, so the NIH, the National Science Foundation, NSH, who does all the investments and grants and so forth, they send the grant papers to the physicists to tell them which ones are the most promising. Well, they're going to tell them the ones that they're working on are the most promising. And so that you get so far down a rat hole.
Like the government unions in California.
Ronald
how
Reagan,
much they deserve.
sure, yeah. And then negotiate with themselves.
That's right.
That's Ronald Reagan's biggest mistake. But so what's happening is, you get to a point where the guys who are making the decisions on the payments are saying, okay, I've been backing CERN now for 40 years. Nothing's coming out of it. We're spending a lot of money on it. But I think if they just do this much more money, we can find something. We're going to find the big bang. And so they keep on throwing good money after bad, but which is bad. But the worst thing is we're educating the next generation of physicists on a model that we know is wrong. But we don't tell them, hey, it may be wrong, a little bit wrong. You should question some of these things. There's no questioning.
Fortunately, there are teenagers in the world. They question everything.
If we had more teenagers running this.
So now you've talked about this as the science of the small and then the science of the very, very large. Can you kind of go through that? Is it like, here's an atom with an electron and proton running around it, and here's the sun and it's got planets running around it? Are those things similar? Are they a part of your theory? What's that about?
So Einstein recognized his mistake. He spent the majority of his career trying to fix it, and he failed. He spent 40 years sort of on the outside trying to fix his error. There's one building block in the physical universe. That's the atom. There's nothing else. The sun is a giant accumulation of atoms. The earth is a large accumulation of atoms. Everything is simply atoms. So theoretically, fourth grade logic, whatever behavior is happening at the atom, scaled should cumulatively represent the behavior of what happens at a large object. So gravity should be the result of whatever's happening in all the parts that make up the body of it. Well, today it is off by, it's off by, I think one physicist said it was like 120 zeros.
So gravity is off by that.
The description of the small or description of the large are off. It's impossible to reconcile them. So logically, the unified theory of physics is what the holy grail is. You remember the Higgs boson? Mm-hmm. The God particle?
Yeah.
Well, they announced they found it. They got their funding for the next expansion of CERN, and that kind of disappeared off. It happens over and over and over again.
But they know how to mark it well.
Fabulous.
They have the Big Bang. They have the boson God particle. They have dark energy. Dark matter.
Dark matter is a great example. We saw something. It was Vera Rubin back in the 1950s. Telescope technology got to a point where we saw galaxies spinning, and Einstein predicted a certain spin rate based on the gravitational theory. Well, the spinning defied Einstein's theory. So you'd think they go, ooh, what's wrong with Einstein's theory? No. Hey, we found dark matter. It's like they made this stuff up. It's completely made up.
To fill in to make the math work. For the equation. And so suddenly they've made it an even more complex equation when the answer is just one.
Yeah. The answer is Einstein made a mistake in the front. But what's funny is, and then that caused another mistake, which means, if you got that much more matter, then the universe must be collapsing. There's dark energy. Fixed it again. But it's the last line of defense for the physics community is a mathematician. If you see something that conflicts, you get two options. One is go out and find out why it conflicts, or the other is discover something that makes the math work. And once the math works, then they put it in a book, teach it to our kids.
So what do you think happens with gravity? I mean, the Earth pulls in gravity, we feel the pull.
Yep.
What's going on? Your theory is that we're all energy sources and uses. Mm-hmm. We're all tied to atoms.
Yep, made up only of atoms.
And we're energy forces.
Yes.
And how is it that my energy force is attached to the Earth now?
So the question that was never answered, that Einstein didn't know existed when he did his theory of relativity, is every atom does work. Every atom's got an electromagnetic field. It's got a nuclei that's active, and it's got a powerful field that we call electron field around it. And the question is, where does the energy come from that allows all that to happen? Well, they make up things called fundamental forces, which is, like perpetual motion. It just happens because it happens. The corrected theory says that there's an energy source, a state of energy in the universe that we don't account for yet, primarily because we haven't looked for it. And that is the ether. It's ether energy. And the entire universe is permeated with this massless energy. And each atom works as if it's a candle. It's sucking in oxygen. Each atom the nuclei is sucking in this massless energy. And as it condenses, it takes on physical form.
So it's as if it were sucking in oxygen. It's sucking in energy.
It's sucking energy. And it uses that energy then to pull the nuclei together, electromagnetic force.
So when you're out in space, there aren't any atoms.
Right.
It's just an energy field.
It's a field, but the fields are moving toward large objects. So the Earth has a ton of atoms in it.
Yeah.
So every atom is attracting energy. So the Earth is attracting energy from a large region of this solar system. And as that energy condenses on the Earth, the concentration per unit volume gets greater and greater until it starts to drag on your body. So what you feel as gravity is actually a field of energy that's passing through you on its way to the body of the Earth.
I see. So it's pulling me because it's energy that wants to pull me in.
Yeah. So you're getting dragged toward the Earth.
So my mass is being dragged toward the Earth. So energy's sort of spewing out of the Earth in some ways.
The Earth is creating an electromagnetic field that extends well out into the place. There's also a couple of other things that are happening to account for the energy balance. But gravity in itself is simply a current of energy that's heading toward the Earth, and you're riding in that current. It will pull you down.
So something I've noticed is that if you got an asteroid, it's a weird shape. It looks just like a dirt clod.
Yeah.
And then as asteroids start coming together, they build moons, and they're perfectly spherical. So sort of they somehow found that shape. And then if they get bigger than the Earth, then they start emanating energy, growing. They grow through this whole thing and emanating energy. And if they get to be as big as Jupiter or the sun, they are emanating a ton of energy. And then if they get really, really big, like sun, then they go supernova, and then it starts over again. You got a bunch of asteroids and whatever else. Tell me, does that gel with your theory?
No. The theory we have today for like the sun is a giant ball of hydrogen, and there's a nuclear fusion transaction at the center, and that's causing luminosity. I think that's wrong. I think the sun is a giant ball of molten material, just like every other object in the solar system, and that the corona of the sun, is where the luminosity comes from, is on the 20,000-mile exterior of the sun. But I do agree that, yes, that is what happens. The life cycle of matter or of objects is you will get to a certain size, you will supernova. You'll create a whole bunch of debris that comes out from the galactic disk. Then over time, that will reorganize itself into planets and asteroids and moons and ultimately more stars. And the stars will then start the organizational patterns of solar systems. But yeah, it is that life cycle of energy that is the one universal constant.
So I was playing around with this, that a black hole is just after, I'm just guessing that a black hole is after the supernova. There's a big thing of gravity there, but the only reason that's happened is that our telescopes can't tell because we're 30,000 light years away from those black holes. So it's gone. It's no longer gravitation, but it was gravitation. Is that a possibility that we're missing the time sink there?
Well, the current theory on a black hole is it is a incredibly dense object that creates all this gravity that holds these stars in rotation 40,000 light years. A light year is 10 trillion kilometers. So 40,000 times 10 trillion. That's how far away it is. A big number. I think it's exactly the opposite. I think that if you look at nature, she repeats herself with something successful when you have an imbalance. So on Earth we have atmospheric imbalances. When there's an atmospheric imbalance, you get a hurricane. It's nature's way of correcting a balance in the atmosphere. You get tornadoes for temperature imbalances. When you flush a toilet, you create a swirl that goes down because you've created an imbalance in the system. The black hole is a location where there is zero mass. So there's nothing to see there.
Mm-hmm.
And every once in a while, a star or a solar system will drop into a black hole, and you end up with these quasars or blazars, these enormous energy transactions that get blasted back out in space. And that's destabilizing all of the energy that is stored in nuclear energy, putting it back into kinetic energy, and going back into the region in space to recreate a balance of energy states. But the whole theory is very simple. It scales from the atom to a galactic swirl mathematically. And there's no gap in there like there's, a big leap of faith, a big jump in some area that, you don't need a big bang. You don't need an expanding universe. You don't need all these things that they've done to protect Einstein's gravitational theory could go away. The entire standard model of physics, particle physics is a dead end. It's been a dead end for 40 years. They've discovered nothing. Now they got textbooks filled with stuff and libraries filled with stuff. They haven't seen a thing.
They're throwing electrons at a wall and blowing them up and then naming the particles that come off of it. And they say they spin this way or that way. They're just hit the wall and then they're spinning.
That's quarks and gluons and muons and anti-muons and green muons and spinning. It's just, but it keeps getting more and more complex and making less and less sense. And then they can write a paper on every time they discover something. That's the other problem with the industry is they got to write papers. If you don't write a paper, you can't get tenure. You don't get your grants. So they're all writing papers. There's an enormous amount of fraud. Hey, would you put my name on your paper? I'll give you $10,000. And they can claim credit for it, even though they haven't even read it. And there's a bunch of podcasts now about that. But we're providing incentives to our physics community that are counterproductive. And we are destroying some of the great minds that we have in each generation through the education process that doesn't allow latitude for creative thinking. You're right. You need entrepreneurs in the physics space. Unfortunately, the way it's structured today, you're not going to get them. They're selected against. But if you want to disrupt something, if you want to help advance the medical sciences and energy sciences and all that, we need a new foundational theory.
So, an entrepreneur might use your theory and create something that uses the energy out there for space travel, and the existing science and physics would be blown away, and then it would be gone, and they'd have to rethink.
If Einstein was never born, we'd be better off. If Einstein lived today, all the information that we've gathered over the last 100 years, he would never have come up with the theory of relativity, general relativity. So it's just, he was a brilliant person in the right place at the right time with the wrong solution. Yeah.
Well, I mean, it's been 100 years. So having, think of what's happened in those 100 years. We got indoor plumbing and we got electricity in the house. We got, smartphones and biotech and all that stuff's happened in that meantime. But there really hasn't been much in the advancement of physics. And, if we're ever going to really get off this planet, we really do need the right theory.
Yeah.
We need to know what makes sense there.
We need to look. They're looking for answers. A theory is a roadmap. You can't prove it correct or incorrect. And it's a roadmap that gives direction to all of our researchers. If the theory's wrong, it sends our researchers north instead of south. You won't find anything. So it's got to change. It will not happen internally. It needs to be disrupted externally. It needs to happen through interviews like this and reaching some young minds that have not yet drinking the Kool-Aid, that haven't sold out to the existing theory. And those are the guys that are going to, if you force a physicist to answer questions without saying, oh, you can't understand the math, use logic, tell me what, they collapse. The whole thing falls apart. But there's nobody out there to do that. But anyway, it's just, but it's conversations like this, my hope, that will reach people that will, over time, make a difference. I don't expect it to happen overnight, but maybe in our lifetimes.
You heard it here first at Talk with Tim. Cree Edwards, totally changing science. Go out there, rethink science, create space travel. Gravity's different from what you think. Energy, we're all sources and uses of energy. Use your energy. Anyway, this was great, Cree.